This video demonstrates how to install VMware's ESX and HP's Virtual SAN appliance, or VSA, onto two bare metal servers. This provides high availability without the expense and complication of a physical SAN. Such a solution is well suited for smaller organizations and for any company that has remote or branch offices. The video shows a complete installation process. It is a compilation of 5 other videos that show specific subsets of this process.
Hi, I'm Adam Carter, the product manager for the HP Virtual SAN appliance, or VSA. In this demonstration video, we're going to be setting up a VMware and Virtual SAN environment end-to-end on bare metal hardware. We're first going to be installing ESX server on bare metal servers. Then we'll be setting up the Virtual SAN appliance on those ESX servers. We'll then be configuring the Virtual SAN appliance and ESX into a clustered architecture that gives us an end-to-end virtualized, highly available environment. We have a pretty simple server setup for this demonstration today, including 2 systems for running ESX server on bare metal, and we'll be installing the Virtual SAN appliance on those. And then we have a top system here for running management, including Windows Server and VMware Virtual Center, or vSphere, server to command this whole virtualized environment. Down below at the bottom, we have a simple switch for running a gigabit network for this entire environment on. The VSA is supported on any ESX or ESXi qualified server. Today, this includes over 100 models of HP ProLiant rack mount and blade systems. There are some best practices, though, that you want to consider as you're building out your VSA configuration. First and foremost is the CPU for this configuration. You want to choose multi-core processors greater than 2 GHz, as the VSA needs at least one 2 GHz core dedicated to itself, and you need additional CPU to run your other virtual machines. You also need to consider the RAM in this environment. The VSA needs 1 to 4 GB of RAM reserved depending on its size. You want additional RAM for running your actual virtual machines. So a typical VSA server has 8 to 16 GB of RAM in it. You also need to consider the RAID controller in this environment. The RAID controllers definitely need to be battery-backed write cache controllers. Otherwise, performance would suffer quite a bit on the Virtual SAN appliance. The disk drives you should choose should be SAS hard drives, 10K RPM or higher, and go with at least 6 in the configuration. In ours today, we'll be using 12. The more hard drives you have in this configuration, the higher random IOPS you're going to get out of your virtualized SAN. Another important item to note is the network configuration required for it. A standalone server that's going to be dedicated to running the VSA would have to have at least 2 gigabit NICs in it. In an environment like we're going to build today, where you have virtualization and VMs shared on the same system as the VSA, then you need at least 4 gigabit network adapters. So now that we've covered the hardware configuration for this setup, we need to install ESX server on bare metal. We're going to go to our systems here and start the installation on this bare metal configuration of 12 drives. The first thing we need to do is carve up our hard drives to be ready to install ESX and the Virtual SAN appliance. In this 12 drive system, I'm going to choose to create a RAID 10 set just for running ESX on. Now that that configuration is finished, we want to create the drives for the VSA's data to live on. The best practice for these drives is to at least have RAID 5, 10, or 6 configured on them so that the drives underneath the VSA have some redundancy. In my configuration here, I'm going to only put 5 hard drives in each RAID set because we can't create RAID sets bigger than 2 terabytes. A bigger than 2 terabytes configuration for any single LUN will not work for ESX servers. An important thing to note here too is that if you were running a server with less hard drives than the 12 we're running here, for example, maybe you're running 6 hard drives or 8 hard drives, a good practice would be to not create the separate LUN for the operating system, but to just create one big RAID 5 set for the whole environment. Now that we've completed the RAID configuration for this server, we can start to install ESX server on it. Now that the server's rebooted after the RAID configuration, we're going to start installing ESX4 on this configuration. For the most part, this installation is a default setup of ESX server. I'll be highlighting any differences to the default setup as we go. Now that the ESX installation is ready for some inputs about how we're going to install it, we're going to select through, choose mostly the defaults. Now that the ESX installation is done loading drivers, we'll enter our serial number. On this screen, we're selecting the network adapter that will be used for managing this configuration. Typically, the default first adapter is fine. We'll use possibly adapter number 2 and 4 as the adapters we'll use for our VSA, configured later after the installation is done. We need to set up an IP address configuration to manage this system. This is not the IP address that we'll be using to actually access the SAN later. We'll configure that in the virtual center client later. We can do just a standard ESX server setup, and we're going to install on that first mirrored set of 2 hard drives that I created, leaving these other 2 block devices for the VSA to use as storage capacity. Now we need to wait for the actual ESX installation to complete. This would normally take anywhere from 5 to 10 minutes to complete the whole process of installation. We'll then be ready to start attaching this ESX server to our virtual center environment and then installing the VSA. Now that the installation is complete for ESX server, we'll reboot this system, and the rest of the installation can be completed from any desktop remotely through all of the software management. Now that ESX server installation is complete, we have a bare metal fresh ESX server. Now we can install the VSA and configure the entire clustered environment. We'll do that from a remote desktop. Now we need to connect to our virtual center server and add our new ESX server to the virtual center configuration. The first thing that we need to do is to add our new ESX server to our data center. This is the server we just installed. After we've completed adding that server to the configuration, we can start installing the virtual SAN appliance on it. While I'm waiting real quick, I'm going to add a second ESX server with a VSA that we've previously set up so that we can show clustering and the high availability for this configuration. Now that we have our ESX server added, we're ready to install the VSA on this ESX server. The VSA comes in a couple different formats. It comes in a zip file that you can extract and upload manually to your ESX server. It also comes in an OVF format that's a little bit easier to import. We're going to import the OVF format onto our ESX server. The OVF allows us some conveniences, such as naming the VSA as our first VSA during the actual import, and automatically selecting network for us. Now the VSA has been deployed successfully. At this point, we simply have a VSA with its operating system intact. We need to create data storage for this VSA to use as the actual configuration it will store data on as a SAN. So first we're going to go to our ESX server and carve up some storage for it to utilize. We go to Storage, and then we're going to add storage to this. The storage we're going to add are the two devices that I left alone during the installation as large sections of RAID 5 disk that we can create for the VSA to use as a virtual disk. I'm going to configure the first one as a virtual disk now. There are some important configuration steps when creating the virtual disks for the VSA. One of the most important is the actual block size. When you format the VMFS data store, you need to select a block size that allows you to create a big enough virtual disk for the VSA to utilize the capacity you have. In this case, I have 1.6 terabytes available, so I need to select the highest level, which will allow up to 2 terabytes to be utilized. If I select a lower level, I would only be allowed to create a 1 terabyte virtual disk at this point. So we'll select the highest block size. If in any doubt, just select the highest block size for the VSA data store. We're going to create another set of storage to utilize the other disk device that we created, since we had 10 hard drives that we were dedicating to the VSA in this case. This is the same process as the previous one. We will also select the highest block size for this configuration of VMFS. Now that we have those two data stores configured, we can add that storage to the VSA as a virtual disk. We'll edit the VSA settings. We will add a virtual hard disk. We're going to create a new virtual hard disk for this, and we're going to select the data stores that we just configured for the VSA to use. I'm going to utilize almost all of the available capacity on that configuration. The intention is to not put anything else on the data store the VSA will be using. This step is very important as the disks for the VSA must be configured as SCSI address 10 to start, and subsequent disks must be 11, 12, and utilized in order. Independent persistent is an important setting to set for the VSA. I'm going to add a second virtual disk to utilize the other device that we created. Just like before, I'm going to select the appropriate data store and utilize almost all of its capacity as the virtual hard disk. Again, a very important step is to make sure it's selected as the right SCSI adapter. I already selected SCSI 10 as the first virtual disk for the VSA. So for the second disk, I'll select SCSI 11. Once again, select independent persistent, and that completes the configuration of our VSA. Now that this VSA has been created, it can be booted up so that we can assign it an IP address and start using it as a virtual SAN. We'll power on the VSA. Now that the new VSA has booted up, we type start to begin the configuration of its IP address. There is no default login. Logins will be configured as we build it as a SAN. All I need to do is give this VSA a name and an IP address. Once that IP address is configured, we are done configuring the VSA inside of Virtual Center. This VM will probably never need to be touched again inside of this interface, other than to power it on if it's been powered off for some reason. Now it's time to install the centralized management console to actually build our virtualized SAN. The centralized management console should be installed on any system you wish to control the SAN from. That can either be your desktop or any management server you choose to run the user interface from. Now we're going to run the CMC for the first time and discover our new SAN storage nodes. Our new SAN storage nodes show up in the user interface as new available nodes, as they have just been assigned an IP address and have not been built into a SAN yet. So at this time, we're going to take our two available virtual SAN appliance nodes, which we have here configured in their available state, with their storage configured as we did through the Virtual Center console with the two large devices. This gives us each VSA with usable space just over 3 terabytes. We're going to take these nodes and create a new management group. This is the building of our new SAN. As we build out our new SAN, we need to define a few things about this SAN, such as what's the name of this SAN. We're going to create a virtual SAN using those 2 nodes. We have to define a user to actually be able to log into the SAN once it's completely built, and this will be the main administrator for that SAN. Subsequent users can be created later. We can choose to either use NTP or a manual time. And one of the steps we want right away as we build our new SAN is to create a cluster. This is the cluster of redundant storage that's going to supply the high available SAN to our virtual environment. At this step, we're going to assign that cluster a virtual IP address. This virtual IP address is the identity of the SAN. No matter what we configure later to this SAN, all hosts, ESX hosts, or other supported operating system hosts will connect to this IP address and see it as the identity of the SAN. This allows us to virtualize the storage and configuration behind it to the point that we can change it, expand it, scale it, do anything we need to administer that SAN without disconnecting the hosts that are accessing it. And the last step of the wizard is to define the first volume, or LUN, that we're going to use out of this SAN. So I'm going to create my first virtual machine LUN. It's configured by default to be a mirrored volume, so that is highly available. And since I'm only going to be placing a few VMs on this, we'll make it just 100 gig. We have the choice of full or thin provisioning. The default is full. I'll accept that for now. At this point, the CMC will go out and configure that entire management group end to end, all the way to having our first storage LUN. This can take anywhere from 2 to maybe up to 10 minutes, depending on how large of a SAN it's building. The wizard has almost entirely completed and is warning us that we haven't licensed our virtual SAN yet. This is okay, as the virtual SAN will allow you to run for up to 30 days without a license using all of the features. Within that time span of 30 days, you should go acquire your license through the web and apply it to these nodes. And with that, we've built our complete virtual SAN. We have a virtual SAN with a cluster of 2 nodes in it, and we have our first LUN with a size of 100 gig, fully provisioned, in a mirrored, highly available configuration. To configure the ESX server to access the virtual SAN, we must go to Storage Adapters on the ESX server and select the iSCSI software adapter. We select Properties on this adapter so that we can configure it to access the SAN. We need to first enable it. And now that it's been enabled, we want to copy this IQN name, which is the identity of this ESX server, and configure the SAN to allow this server to authenticate to it. Real quickly, I'm going to add in the dynamic discovery list the IP address of the virtual IP for the cluster. As mentioned before, this is the identity of the SAN as far as any host connecting to it is concerned. I'm not going to rescan at this moment because I haven't configured authentication yet. We must do this on any of the ESX servers that we want to access the virtual SAN. So we're going to go to our second ESX server and configure its iSCSI software adapter. Just like the other server, we enable it, and we'll come back to copy this in a second. In the virtual SAN interface, we configure the servers, these would be the ESX servers, that are going to be allowed to access this SAN. We'll create ESX server 1, and this is where I'm pasting in that IQN name I copied earlier. I'll create server 2, and I want to go copy and paste the IQN name of the second ESX server. To finish that configuration, now that we have servers in this interface, we want to go to the volume and assign servers to it. We're going to select that both of those servers, as this is a clustered configuration of ESX servers, are allowed to access that volume, read-write. When we select OK, we get a warning that this should only be done for clustered servers, like ESX and Microsoft clusters. So now those ESX servers are allowed to connect to this iSCSI volume. You can see that when you select the servers that they list that volume as something they're allowed to connect to. Back again at the iSCSI settings of the ESX server, the second server still needs to be pointed at the virtual IP address of the SAN. And at this time, this is a good time to go ahead and rescan looking for that new storage. As the rescan looking for that new storage is going on, we can see in the centralized management console that the LUN has been connected to by ESX server 2. It shows a connection under gateway connection for that LUN. ESX server 1 does not yet because we haven't rescanned it yet. We'll do that now. Looking at the centralized management console, we see that both servers are connected to that LUN now. We can see that on the LUN itself also that there are 2 sessions connected to that LUN. So at this time, we have an iSCSI volume shared out to both ESX servers, ready for us to place virtual machines into our environment on a SAN. Since the LUN has been connected, the next thing we want to do to it is actually configure it as VMFS storage to start placing virtual machines on. Now that the LUN's been created and connected, we want to format it as VMFS storage for virtual machines to be placed on. We can do that on either of the ESX servers, and we only need to do it once. We'll add storage. This is a new disk or LUN, and we'll see that the iSCSI disk has shown up in the capacity that we defined when we created that LUN, the 100 gig. We'll format that VMFS. And with that, we're ready to start placing virtual machines on our virtual SAN and using any of VMware's features that require shared storage, such as vMotion, DRS, high availability, or fault tolerance. We're going to create our first virtual machine on that shared storage. I'm going to create a pretty simple new virtual machine, and I'm going to place it instead of on any of the local storage, which isn't highly available if any particular server in this environment fails. I'm going to place the virtual machine on the virtual SAN LUN instead of on the internal storage, which is not highly available. This virtual SAN LUN allows me to use VMware features. We're going to choose a standard 32-bit install of Windows 2003. Just select whatever settings match the needs for my virtual server. With that, we're ready to install our first virtual machine. That completes our demonstration and installation. What we've done is virtualized our servers to build virtual machines using VMware ESX. And we've also virtualized our storage using the HP Virtual SAN appliance. Our configuration is now a completely virtualized SAN using only the internal components of our ESX servers. There's no external SAN hardware required at all. We also have extra capacity for running virtual servers in this same environment. This provides us a complete IT environment that's 100% virtualized end-to-end, all at a lower cost and using less space and less power, which makes it a wonderful solution for remote offices and smaller businesses. For more information, please visit our website at www.hp.com/go/VSA. I hope this helps you build your virtual SAN environment. Thank you.